So the final module in our selection topic is actually kind of a repeat of the previous module, multi-selection. But the thing is, we're going to do it in a whole other way. But it's essentially going to result in the same effect, more or less. So the question you should be asking yourself is, why on earth would you teach me the same thing twice? Well, to answer that, you really need to delve into what it means to be a programmer. And to be a good programmer, you're often bombarded by decisions. And those decisions are based on the context that you're in terms of the software that you're building. But really, you're always trying to answer and solve one little riddle: efficiency. Efficiency in computer programs are measured in two things: space and time, how much memory it takes up, and how fast it can be executed. Now, in every scenario, you're going to be looking at those two things to make your decision to choose whether you should use an if-else-if statement, which we learned yesterday, or use what it is we're going to learn today, something called a switch statement. So what I want you to do is I want you to keep that in mind as we go through the lesson. So just going back to our little note-taking sheet here, I'm going to go over the syntax of what a switch statement is. And remember, it's just another form of multi-selection, the idea of making infinite choices within our program. So the syntax for our switch statement is not too bad. Let's say, for example, we use the keyword switch, and in brackets, inside of here, we're going to have some form of variable. Okay, now I'm kind of generalizing here, and I say variable because that's typically what is used. In actuality, it can really be any expression. That expression just must be resulting in certain data types. So one of the key restrictions on using a switch statement is that this variable can only be certain types. For example, it can only be an int, a bool, or a string. It could be a few others, but for the most part of the ones that we've discussed, we're going to keep it to int, bool, or string. Now, that means that you're forced, if you have some form of expression that evaluates to some form of result, it must actually be one of these data types when it finishes up. So continue on with the syntax. We have our opening bracket like we do with any other type of large-scale statement. And then inside, this is where we do our comparisons. The comparisons aren't the same as they were with an if-else-if statement. So to do this, we use a keyword case, lowercase c. Case, and then we have a value. Now this is actually a literal value. So for example, it might be a 5 or a word that's in quotes or something like that. It can't be a variable. The only things it can be are literal values and constants. It can't be anything else. And the reason for this is just the way the C# and most other languages actually handle these switch statements to make them fast. So what happens is we have this case and then the value. Then inside of that, indented in, no brackets this time, no braces or curly brackets or anything like that, we have code that executes, that runs, when value exactly equals variable. Remember, variable is just the value up here at the top. So that means it must exactly equal. What that should tell you is that all we can check is equality. We can't check less than, we can't check greater than, we can't check not equal to. All we can check is equality. So that's another limitation. So we're limited by the data types we can use, and we're limited by the fact that we can only check for equality. That means it's impossible to build ranges because I can't say greater than this value and less than this value. I can only check equality. So there's some limitations on using this. So you must be thinking to yourself, why in the world would we use this? Well, let me finish and then we'll get into that. So once you're done the code, the last statement that needs to be here is something called a break statement. And it kind of works, it kind of emulates what an if-else-if statement does, which says once you're done executing the code inside of the valid true or the valid else-if check or if check, immediately skip the rest. Well, that's what the break statement does. It says break out of the switch statement and skip all the rest of the code below. So in order to do this, we need more case statements. So you might have another one. So it might have something like this: case value 2. again, a colon. These are colons, not semicolons. And this is code that runs when value exactly equals variable. And I just need to modify these. Sorry, this should be value 1 and this should be value 2. And then we need our break statement. What I want to point out, though, is that notice that it doesn't say anything about the previous value or the previous case. And the reason being is because it doesn't care. Because we're always checking for equality, there's only ever going to be one valid option, one valid case. And the reason why they use that keyword case is because in the English language, you might, when you're talking about multiple different options to someone, you might say something like, well, in this case, do this. In this case, do that. In that case over there, do that. So it's just a terminology that they've tried to use from the English language. Now we can have as many of these cases as we want. Infinite number. But when we're all done, we have this final piece called a default. In this case, we're not comparing any specific value. This is just like our default case. So if all of the other ones were invalid, it's going to run the code here. So code that runs when variable did not equal any of the above values. And then we still need our break statement. And then we close off our switch statement with our closing squiggly bracket. And that's it. That's our entire syntax. So you notice that we have as many cases as we want, and they have values. And then we have our break statements at the end of each case statement, and then we finish off the default. Now if you were to try to compare this to an if-else-if statement, this would kind of be the same thing as saying, if variable is equal to value 1, do this code. Else if variable is equal to value 2, do this code. And so on and so forth. And then finally, the default would be equivalent of saying else. It's your safety net. Whatever's left over. For all the values that we checked, this is what's left over. And if it didn't go into any of the previous ones, go into this one no matter what. And just like the else code, the default is also optional. You do not have to have it inside of your switch statements. So let's go to the code and actually create a simple little example that will actually illustrate this. So I've created this program so far that just asks the user for their age and stores it in there. And now we're going to create our switch statement. So we're going to say switch. The variable we're going to be comparing against is of course that age variable that we just created above. And I have my opening and closing brackets, which I create immediately so I don't forget any of them. And then inside of here I start doing my case statements. Okay. So my first thing, I'm going to have case, and that's going to be a very simple program, and it's just going to say the stages of getting your license in Canada. So for example, at stage 16, the value 16, we can start doing our code, console.writeLine get your G1. And typically a year after that, you'll get your G2. So we'll have another case, case 17, we have console.writeLine get your G2, which is kind of like the second stage. You're allowed to drive without somebody else in the vehicle with you. You just can't go on any major highways at that point. And then we're going to have case 18, which is fairly typical. At this point, you're capable of getting your full license. Console.writeLine. I see I have a typo above, which I'll fix in a second. Get your full G. Just quickly fix this right line above up here. And then we're going to end this, and we got to put our break statement in. And we're going to put a default. We'll just put something in here like, I don't know, you may or may not already have your license, depending on if they're less than 16 or older than 18. Fix this up right here. So if we look at the syntax, just quickly, we forgot our break statement inside the default. If we look at the syntax here, it's going to say, okay, well, whatever the user entered in, did the user enter 16? If the user entered 16, it's going to go in here and say, get your G1. If the user entered 17, it's going to go say, get your G2. If the user entered 18, it's going to say, get your full G. In any other case, it's going to go down here and say, you may or may not have your license. So if we run this program, let's just try it out a couple times quickly. Let's put in 17. And we say, go get your G2. Simple. Let's run it again. Let's put in 12. You may or may not have your license because you're not 15, you're not 16, 17, or 18. So we can see that it's going to go in the correct one. Now this is where it differs from an if-else-if statement. With an if-else-if statement, it kind of works like a hard drive. It does everything sequentially. It goes through piece by piece. So it's going to check the first option, then it's going to check the second option, then it's going to check the third option till it finds the valid option. It's going to run the code in that valid option, then skip the rest. So that works kind of like a hard drive does, and it's a little bit slower. Whereas a switch statement operates similar to RAM, immediate direct access. There is no scanning. It immediately goes to the correct one. It doesn't go to 16, then 17, then 18, then default. It just goes to the correct one. It ignores all those things. That's why there's all these limitations and restrictions on this stuff. The fact that you can only check equality. The fact that you can only have literal values, because it pre-computes all the different options. And then it creates kind of like a lookup table or a table of contents that says when the user enters this, go directly here, like a mapping. Right? So whenever this value is this, go directly to this location. Ignore all the other ones. So just to illustrate this, what I'm going to do is I'm going to put a breakpoint in our code right here at the switch statement. I'm going to run the program, and I'm going to put the value 18 in so you can see how this works. So immediately it's paused on this point, and now it's at the switch code. And you can see that age currently has the value 18. What I'm going to do is I can now step through this code using the F10 key, and what it should do, it should go directly to case 18. Which it does. It didn't go through any of the other options, it just immediately went to the right one. It's going to run that code. It's going to break. Now watch what happens when it breaks. It doesn't go to the default, it ignores it, it continues on with the code, and goes right down to the final console.read line. And when I hit F10 again, it's going to go right to the output statement, and you can see that everything is the way we expected. Just close that off, and we can stop this now. We don't need this to keep going. So we can see that it's always going to only go to the correct one. We can ignore all the other ones. We don't have to worry about it. This makes it a lot faster. But of course, as we've seen before, there's a lot more restrictions.